I bought the cheapest mini crossbow I could find on Amazon to answer one question. Could I mod it to match the power of a $2,000 professional crossbow? I got this for 49 bucks. It's mostly plastic with a 70-pound bow. It's basically a toy, but that's about to change. The first thing I wanted to do is see how fast this thing's shooting out of the box. After a few shots through the chrono, it seems to be shooting right at about 180 feet per second. My first idea was to build a dual propulsion system, basically a crossbow and an airbow working together at the same time. This bow pulls from the front, and this CO2-powered air tube pushes the arrow from behind. I mounted the air tube in the crossbow just above the rail. Then I glued on an external nock on the side of the arrow. The string sits down here in this notch, then gets pushed up by the release mechanism. The string then starts to move forward, catching the external nock, and at the same time, the air valve is open. After shooting this a few times, it's only getting up to about 240 feet per second. That's a small gain, but nowhere near what I was hoping for. I think there's two things that would need to be changed to make this actually work well. One, I'd need to step up to a PCP tank and valve running at around 3000 psi. I was just using low pressure for this test. Then second, and probably most important, I'd need some kind of adjustable timing device to sync the string release perfectly with the air valve, then use high-speed photography to dial it in. But that's getting a little too complex, so I'm shelving the dual propulsion system idea for now. So back over to the drawing board here. I'm going to go in a little different direction. I think I'm going to get rid of the bow entirely and go full airbow. Then for air pressure, I'm going to ditch the air cylinder and bring in a red 27 tool load. First thing I need to do is to test the arrow material to see if they can actually handle the higher pressure. So I made this test dam to mount the air tube in to test it. Then I mounted an air cylinder hammer behind it for tool load actuation. This is the result of the first arrow test, which I didn't record. As you can see here, the stock arrow material didn't handle the pressure very well, so I will have to make my own custom arrows for this. The stock arrows are 11/32 OD by 5/16 ID, giving them a 16 thousandths wall thickness. So I will make my arrows out of 3/8 2024 aluminum with the 5/16 ID, giving them double the wall thickness at 32 thousandths. I'll also thread the ends of the arrows because the standard glue and inserts won't handle the pressure. I made this little fletching jig to glue the fins onto my arrow shafts. Running these arrows through the chrono, I'm getting around 660 feet per second, which is not bad considering the air tube's only 4.5 inches long. One thing I did find is that it's hard to stop 5-inch long arrows without damaging them. Then I decided to try making some different types of arrows for this thing. Besides the standard arrow, I need a Nerf arrow and a knife arrow. But then I got to thinking, what would happen if you made a micro arrow and ran it on the inside of the air tube instead of the outside? So this is what I come up with. On my first shots with these micro arrows, I noticed that they were fragmenting into 3 or 4 pieces. After some close examination of the arrow parts, I found that the aluminum tube that I was using for the arrow shaft was completely smashing flat from being accelerated from 0 to 3,000 feet per second in 4 inches. So then I started making the arrow shafts out of fiberglass and solid aluminum drilled out to a thicker wall. The other problem that I was having was the chrono kept getting errors from the blast of the air tube that's only 2 feet away. So I made this baffle system where the arrow goes through a piece of cardstock covering a hole in a partition that separates the air tube from the chrono. This stops about 90% of the blast from the air tube. Running these micro arrows through the chrono, I'm getting anywhere from 2,700 to 3,200 feet per second, depending upon the length, weight, and material used in the arrow. Which got me to thinking, could I hit 4K with this thing? So I set out to make a really light and fast arrow. So this is the lightest and fastest arrow that I could make. It has a Dell ring tail, carbon fiber shaft, and a 70-75 tip. This is tipping the scales at just over 0.5 gram. Well, I didn't get to 4K, but 3,500 is smoking fast for a 4.5-inch air tube. Now all I have to do is mount the air tube on the Crossbow stock. My first thought was to mount the air tube on the bottom of the Picatinny rail and keep the Crossbow up on top. But I kind of want to make this as small and compact as possible, so I think we'll mount it up on top and cut off the stock. So here's the completed mini crossbow turned airbow. I'm going to see if I can't slice the squash up in 4 equal quarters with the knife arrow. Might be a handy little gadget to take to the picnic. Alright, if you've watched this far, you're probably wondering why I haven't taken this thing out shot. Well, if you look at most airbows, they almost always have a shroud around the arrow. This is for 2 reasons. One, the air tube can get bent because it has a fairly thin wall, and second, to containing arrow if it blows out. The larger you make the hole in the air tube, and the thinner you make the wall on the arrow, the better the airbow will perform, but with a higher risk of the arrow or the air tube blowing open. I'm definitely pushing the limits of wall thickness on this airbow, so I would not actually take this out or shoot it until I get a shroud around the arrow. I will probably mount a piece of 1 3/8 chromoly tubing on here like this, similar to this airbow here. This should contain a rapid unscheduled disassembly of either the arrow or air tube. Well, maybe just once.